Hey guys, Joe Small Home Off Grid Prepping. So today we're going through the whole system. I got this thing all in, I got it up, I got it running. It's a fairly cloudy day today. I'll show you guys in a second here, but this charger is doing 12.11, right around 12. And we got this guy over here doing right around 10. It is a bit of a cloudy day. Let me show you guys real quick. Yeah, you see the clouds up there. We don't have a lot of sun today. But we're still putting out 20 some odd amps here with the clouds being like this here. And it's based kind of on what we're running here. So we'll break down some amperage in a minute and I'll show you guys here. But yeah, you can see all the clouds and everything like that here. Beautiful, beautiful spring though. You see all the trees waking up. Everything's nice here. And I'll show you my garden real quick here. Look at those tomatoes. Those things are, oh my gosh, they're beautiful. These things are just incredible. And look at all the blooms on them. And we got all kinds of tomatoes coming up already here. That cabbage, look at the size of this cabbage over here. We've got more tomatoes going over here. You see another cabbage back over there. And eggplants. Oh, let me show you my eggplant real quick. You guys can see that. Look at that thing. That is beautiful. It's getting nice and big, popping up, and we have more getting ready to bloom over here. And we come over here and look at all these tomatoes popping in here. They're just all over the place. Yeah, beautiful, beautiful, beautiful tomatoes coming in here. And another cabbage. So yeah, this is why I've been kind of slow on my videos. We've been real busy with this stuff here, with this garden and everything like that. This is everything's just doing beautiful over here. We got some lettuce going on over here. So yeah, that's what we've been busy with here, guys. So but like I said, today I'm going through my entire solar system here to show you everything that we have going. Just show you the cucumbers real quick. These things are going crazy. And I forget, my wife planted that. I think those are beans. I don't know, I don't remember. But look at these cucumbers. Is that bush crazy? And look at here. Let's see, we probably got a few. Oh, you see right down there. Yeah, look at that. Look at the size of that one coming up over there. And she picked a bunch, but here we got more coming up over here and over there. There's a few more. They're just now starting to bloom and take off here, but yeah, look at these, one back over there. So yeah, these things are doing beautiful. There's a little one coming up over here. So yeah, this is what we've been busy with. This and a lot of stuff. It's springtime here, so it's beautiful. So, well, let's get back to the solar. Alright, so we're going to start with the batteries. I'm going to show you guys how I wired into the batteries here and what I did. This is in parallel, not series. So basically the batteries here are just connected together. This is the going to the power inverter right over here. So this is the main power feed. This is a charge wire right over here that's coming up. And you see this jumps from here to this battery, then from here to this battery, and so on. So the thing is though, guys, if you see over here on the positive, okay, you don't see the wire, the wire for the inverter. It's on the opposite side. So this one is on this side and the other one is on this side over here with this battery down over here. It's kind of hard to see, but the reason is when you wire these things up, this becomes one gigantic battery. And if I were to put the negative here and the positive here, that means when I have a heavy load on this, it's going to be dumping this battery first and then going from this one then to this one. Okay, so by putting one here and one on the opposite end, you're helping to drain the batteries more evenly, and it will make your batteries last a lot longer. And with the solar on right now, we're pulling, well, according to this, it's going to be somewhere around 20 some odd amps coming in. I'll throw the probe on in a second here. But with your batteries, like I said, this is in parallel here. And again, you want the charge wire on one side and the other charge wire is on the opposite side. And same thing with the load over here. Now you notice I did put these two together, okay? And the reason being, when this is pulling a load over here, this is going to sense it and it's going to compensate. If I had put this all the way back over here on the back end, then it would have to go through all these batteries first, and the charge controller wouldn't put out as much amps. So over here, with it being over here, it's sensing a heavier load, so the charge controller reaches its maximum point a lot easier, a lot quicker here. So that's how the batteries are wired. Like I said, when you're wiring in parallel, you just go from negative to negative to negative, and then from positive to positive to positive back over there. But let's get a couple readings here, and I'll show you how all this works. Okay, so we're pulling 17.7, right around 18 amps right now. Everything in the house is on, refrigerator's running and all that. I do have the air conditioner, looks like it's just kicking in. Well, actually, that might have been a refrigerator. The air conditioner would have went a bit higher here. The refrigerator does cycle on and off, so, but we're up to 24 amps, which that's about right here with the AC unit off. We put the AC unit down to about 69 at night, so I woke up this morning around 7:30, 8 o'clock in that area, and I put the solar on. It's all been running since then. It's probably about 12:30 in the afternoon right now, and you guys saw we don't have a lot of sun. So this is pulling 24 amps, and let's see what the... we're pretty well almost even. We're slightly above, so we're still producing more power than we're taking here, even in these clouds. If I were to put the air conditioner back on, then that would change. I would be using more. The thing is, though, the house is still 74 degrees right now. This house is super insulated. If you guys have seen the videos on the house, one of the first ones we have, we put in the spray insulation. And the entire house, when I designed it, was designed for this kind of solar system. The two were designed in mind together. That's why I pull such little amps on this, and I needed such little solar here. But that's the battery bank, okay? So let's see here when we're... Well, here, I'm going to hook this up here real quick. Okay, so you see here, this is connected from this one over here, this first battery, over to here, and that is what we're reading right now. We're reading the draw that's coming from this battery to this one, okay? And as you see here, that's only like 1.4 amps. That's because the solar is making up the difference. Now, let me show you what happens when I turn off the panels. Okay, so you see here, the first battery is pulling pretty close to 6 amps off the second battery. Reason being is this charge from the solar is compensating the difference here. The solar, we're around 17 to 18 amps from what I'm looking at right now. So like I said, this is only going to take 5.5 from here because the solar makes up the difference. Now, let me show you what happens when we turn off the solar and we're not putting this extra power into the batteries. So you see instantly here, as soon as the solar goes off, we jumped all the way up to 19.6. And if you figure that's about the difference what the solar was putting in, now we're up to 20. So the solar was putting in the difference. So this battery right here was barely being used. Most of it was coming off of this battery here. So that's why you wire these with, like I said, this on this end and that on this end, because it helps to keep these batteries more even. If I were to go to the positive, which is on this side, and check the same thing, but it's all the way in the back, so I normally work on the negative here, I would get the same exact readings that are going on over here. So like I said, by wiring these with one side of the load on here and the other side of the load on the opposite, it more helps you to make the batteries drain more evenly, and they will last a lot longer. Same thing with the charging. And you put the charging right here, because like I said before, you see the difference in the amperage now. If I were to connect the charger down on this end of the battery over here, where's my fingers? Down over here, then like I said, the current would be going through here, 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 here before it reaches up over to this load wire here, which is powering the inverter, which is essentially powering the house over here. So this is why you wire batteries like this. They're going to last a lot longer. So that's the battery bank. Not a lot to it, guys. So let's move up next. And this wire here and the red one, well, you can't really see it. I'll come up from the back. But this wire here and the red one are these two wires over here, okay? These are going into the back of my inverter. And this here, I don't have one. I'm going to be getting it. You really should, when you wire this in, you should have a switch on one of these. They actually have push button switches that you can just push it in, and it disconnects your inverter. This is coming directly off of the batteries. I'm not going to leave it that way. I am going to change that, but this is what powers up the inverter, okay? This is a split phase inverter. This thing is a beast. You guys have heard me talk about this a little bit here, and I mean, this thing has been working so good. I put this in about 2 months ago, and I've been so impressed with this that I actually set up with this company. We actually carry these on our sites. I'll include a link because they're quite inexpensive. They're split phase. This is the 6000 over here, and I'm happy with the 6000. If you watch my last video, like I said, I'll probably upgrade to the 8000 just for a couple reasons. One, I don't need the wattage, okay? The 8000 has a couple different features in it. One, it has a battery charger in it, which is great if you guys are in a situation where you can't put solar in your house, or whatever it happens, you know, have no reason you can do an off-grid solar system like this, because this is basically a generator, a solar generator. and I'll show you how we connected it if you haven't seen the videos. But like I said, the newer ones, the 8000s, two things. They have a built-in battery charger, so you don't need any solar for them. You can just have a battery bank set up like what I have over here, make it as big as you want, and during normal times of the year when your utility power's on and the power company power's on, the batteries will be charging. So if your power goes out, it will stay, the batteries are completely charged. When the power goes out, you just flip on your inverter and you guys have power. That's it. It's that simple. You don't need solar, so they're kind of solarless, but at the same time, they could be charged on solar, just like what I have over here. So like I said, I'm going to include a link to all this for you guys here. These are low-frequency inverters. They're made for heavy-duty loads, like starting up air conditioners and starting up well pumps and stuff like that here. Still, I have not tried this on my well pump, but I know that this, from this distance, would not work because my well pump is about 300 feet away from here. And all the wiring is actually derated, and it's way, way larger than what it would need to be, but I still doubt this thing would work from there. When you guys size up your inverters, and you're sizing up your system, what you want to run and everything like that. This is a 6,060 watt battery bank, 6,000 watt inverter, 3,000 continuous, okay? 6,000 is a normal surge, but as you see here, there's 24,000 watts peak, okay? That is for a split second, and it will work for a split second. If you have a motor that needs that kind of wattage to start up, this thing will give you that kind of wattage for a very split second, which is all it takes. That's all it needs it for. Problem is you will not get more out of a power inverter than what you have in the batteries, okay? So I have a 6,060 watt batteries, excluding when this thing is running on solar, because when the solar's there and I'm charging this thing up, you guys know I have a lot more wattage than that. But like I said, this thing here, you will not get more out of your inverter than you get out of your batteries. So if I wanted 24,000 volts out of the batteries to start something up with a heavy-duty load, I would have to have 4 times the amount of batteries that I have over here. Actually 3 times. I'd have to have this and then 3 times more to equal 24,000 watts. So you're not going to get more wattage out of your batteries. So no matter what the inverter is, you can have a 10,000 watt inverter, okay? But if you cannot supply that with 10,000 watts through the batteries or solar, then it's just simply not going to work, all right? So, like I said, the other difference in the 8,000 compared to the 6,000 is this here, you see, I'll show you guys real quick here. Here you go. The fan just kicked on, too, which is nice. So you can hear the fan running. The fan is a little bit loud, but it has to be, okay? This thing has a massive fan. You guys can't see it, but the amount of air that's blowing through here, all of these holes down over here, all of this is stamped through, all of this is stamped through, all that, all of this, nothing's printed here. These are all stamped in the plate. So the air is coming through all this, and then also the fan over here on the side, and there's one on the other side as well. So these things are just really, really, really incredible. I'm very impressed with this. Like I said, it works perfect. And I'm going to show you guys the voltage real quick here. AC volts. So we're just going to check L1 and L2 right over here. And so we have 230 volts, okay, a little over 230. So that is perfect for me. My air conditioner is 230, my pool pump is 115, my refrigerator is 115, TV is 115, so everything in here is set up perfect for mine. The thing is though, 230, 240, even if I had stuff that was set up on 240, I would have no problem running that on 230. But the difference is, like I said, I like the option, and the 8,000 comes with an adjustment right over here that you can adjust it from 110 to 220, 115 to 230, or you can adjust it from 120 to 240. So, like I said, I'm probably going to upgrade eventually to the 8,000 and keep this as a spare in case SHTF hits or something like that, and I need an extra inverter. I'm going to have it. So, but otherwise, if you're sizing up your inverters, guys, like I started to say, I'm going to use a rule of thumb of 1/3. This is 3,000 watts continuous, okay? 6,000 for, I forget how long, 5, 10 seconds, whatever. It isn't a lot. It might be a little bit more than that. But anyways, and then 24,000 for a split second. But look at the continuous, okay? This is 3,000 watts continuous. At the most, I'm like 800, 900 watts. So I never put more of a load on this thing than about 1/3. And that's what I'm recommending to you guys. If you want your system to last a long, long time and have no problems with it, don't put the maximum load on. Don't buy a 3,000 watt inverter and then start using 25, 26, 1,000 watt, 100 watts. You got to burn it out quicker, okay? You're putting too big of a load on it. So, like I said, I'm recommending 1/3. I'm about 800, 1,000, whatever on this, and this is 3,000 continuous. So, again, I'm going to include a link to our site. On our Etsy site, we have a lot more than this here. We have a lot of great inverters there. The price is extremely economical. So basically that is your inverter, that is the high voltage system here. This comes into the disconnect over here, and then let me show you guys what goes from there. Okay, so this is it, guys, and you can still hear the fan running on the inverter here. If you've seen our other solar videos, then you guys were around and saw this when I put this in over here. It's identical to the generator, and in a couple days I'm going to do a video getting ready for hurricane season. I'm breaking out my generator, and I'm going to fire it up, connect it to the house, do all that there. So I'll do a video on that and show you guys there. But like I said, this is the receptacle over here that's connected to the power inverter through the disconnect I showed you. And then this is the generator cord. And again, you guys have seen the video that we made on connecting the generator to the house. Well, that's it. This is how my solar is connected to the house. And if I wanted to use a generator, I would simply unplug this over here and I'd plug it into the generator. Okay, and that's it. So then, this is the interlock. And again, you guys have seen my video. If you haven't, you know, we'll include some of these at the end, but just go to our channel and you guys will see all these here. So this is the interlock. Right now the solar is running on the house here. So you see the main breaker's turned off. And the way this works is the main breaker's turned off, and now I can't turn this main breaker on. Okay, it hits this plate right here if I try to turn it on. Opposite times, okay, this one here would be down. Well, let me show you here because we can put the solar off at this point. So this one here would be down, and you see that dropped over there. So now I just turned the solar off to the house, but the main is still on. So let's put the main power back on here, and that's how your interlock works. So now I can't turn on the generator breaker or the solar breaker unless I turn off. You see here, this goes up and it hits the handle right over here and keeps this from being turned on right over here. So you can never have the two on at the same time. So then I can just basically flip this one back over here and flip that one back like that, and now our solar is back on. Okay, and the same thing with the generator. So this interlock will prevent you from ever having these two on at the same time over here, and that is how this is connected to the house. And you guys have seen the panels already up on the shed over here, but that's the panel system over here. So the panels basically go from the roof, they're wired down into the shed and connect to the charge controllers. And here's, I've showed you the last video. I'm not sure if you guys seen it. I won't get a lot into this because we just did a video on this here, but turn these back on. The solar's turned off here. That's the breakers for it. So basically what you have, guys, you have the solar panels up on the roof. They come down into these breakers over here, right? Okay. Then they go through the PV connections, which are this side here, into this charge controller, and then this side here into this charge controller, right? So then the charging wires, and again, I'm not going to get into the resistance and everything I got into last time. You guys can watch my last video on the Renogy charge controllers, which I'll explain. That explains all the resistance and why this is the primary and this one's a secondary. But anyways, these are the charge wires, come down, connect over here, and then come into a fuse right over here. This is an 80 amp fuse right over here. It's just one of these plug-in cartridge fuses, and like I said, it's 80 amp right over there, and that just plugs in. That is more expensive than breakers, and then you just plug that back in. The thing is, I had that. I was using that a long time ago. I had it. I think those are around $20, $25 to buy those things. So then from there, okay, it goes to the charge controllers. Then you have the charge wire here, and you have this charge wire down over here, which are both going down over there, and that is these wires that come in there, and they charge your batteries, okay? So from there, again, you have these big feeder wires, and there's a red one. Those come into the back of your power inverter. Those supply DC power to the power inverter, and this is a 12 volt. We have 12 volts, 24, 48. We got a lot of options for you guys, so again, just look for the link at the end of this. So from there, that powers up your charge controller, your power inverter, and then this is where the connections are made into the power inverter, okay? And it comes through this pipe over here, goes into this disconnect right over here, and then this pipe right over here is where I just showed you the cord is plugged in. Okay, we trenched it, we buried it. So that is my whole solar setup. Like I said, my house is set up to where I can run on a generator and plug it in, or I can plug my solar in. Either way. And you see here, this one is putting out 12 amps. This one's pretty fairly even. So let's take another quick look at what the solar's doing. Okay, so, alright, so the house is pulling 19.3 amps right now. Obviously AC unit's still not on, but everything else is, refrigerator, TV, you know, stove, everything like that, it's all back on here. And let's see what we're putting in to the house. 30, right about 30. So putting in about 11 amps more than what we're actually using. So like I said, I'm producing power here. This is my power plant. So that's it, guys. That's how simple solar is. Like I said, I'm going to include the link to Etsy, our Etsy site here, and we have these inverters over there. We've got some more things out there as well. You guys have any questions, you'll be able to get a hold of me. Comment here. You like what you see in here, like, subscribe, hit the notification button. And, you know, like I said, this is my setup. Solar panels come into the breakers, breakers go into the charge controllers, charge controllers go to the battery, charge the battery, battery comes back up to the inverter, supplies the inverter, turns it into AC voltage, goes and connects to my house, the receptacle, and an interlock kit. Super, super simple, identical to a generator, guys. So like I said, I'm going to include the link here. If you guys have any questions, like I said, comment down on the bottom. On our Etsy site, you can get a hold of me. So, you know, if you have any questions, let us know. But other than that, guys, that's it. That's our solar. Alright guys, so yeah, like I said, I'm going to do, hooking up my generator in a couple days. I'm going to fire that up and get it ready, make sure it's good for hurricane season. So look out for that one. Like I said, if you guys like what you see here, like, subscribe, hit the notification button, and we've got a lot more coming up. So, alright guys, have a great day.